Welcome back to Test Equipment Chronicles with Bob. I'm Bob, and today we're going to walk through basic generator testing. This is one of those subjects that still matters. Maybe not every day in a modern repair shop, but it absolutely still matters in the world of collector cars, old tractors, vintage farm equipment, industrial engines, and older utility machines. Around my place, these generators still show up. So I want to explain this the same way I have explained it to many people over the phone. A local farmer, a collector car owner, a fellow standing in a shed with an old tractor and a weak battery. He does not have a test bench. He does not have factory service information spread across the workbench. He may not even have a schematic. What he does have is the machine, a few hand tools, a test lamp he can make in a few minutes, and the willingness to learn. So that is how I want to teach this. Just you and me, standing beside the machine, talking it through, and once you understand the logic of a generator system, they stop being mysterious. They actually make very good sense. Now the first thing I want to settle in your mind is this. A generator is not tested the same way as an alternator. That is the first rule. Yes, both machines convert rotation into electrical energy. That part is true. But the way a generator begins charging is different, and the way it joins the electrical system is different. A generator has to begin building voltage on its own. It starts with residual magnetism in the pole shoes. That little bit of leftover magnetism is enough to get the process started. As the armature turns in that magnetic field, voltage begins to appear. That voltage starts feeding the field circuit. The field becomes stronger. Output builds on itself. Then, once generator voltage rises high enough, the cutout relay closes. At that point, the generator is connected to the battery and the rest of the system. That means one very important thing. A generator must be able to self-start electrically. And that point is critical, because if all you do is apply battery power and make the generator spin like a motor, you have only proved that it can motor. That is useful, but it is not the final proof that it will charge properly on the machine. So I want to separate those ideas. Motor testing tells you something. Self-start testing tells you something more important. And system testing with the regulator tells you the rest of the story. Now let's build the system in plain language. When I talk someone through one of these over the phone, the first thing I do is have them identify the terminals. Most generators will have an armature terminal. That may be marked A or ARM. That is your main output terminal from the generator. Then you usually have a field terminal. That is marked F or FLD. That terminal is part of the field circuit. And a field circuit is how the regulator controls output. Then you have ground. Sometimes the generator case itself is the ground path through the mounting brackets and the engine block. Sometimes there is also a dedicated ground wire. Either way, if the ground path is poor, your testing is going to get confusing in a hurry. Now let's move over to the regulator. A regulator on one of these systems will commonly have terminals marked BAT, ARM or GEN, and FLD. Sometimes you may also see GRD. Sometimes you may see L for load. Here is the simple explanation. BAT is the battery side of the system. ARM or GEN connects to the generator armature terminal. FLD connects to the generator field terminal. GRD, if present, is your intentional ground. And L, if the system uses it, feeds loads. That is not the same as the armature connection. Now this matters because once people lose track of the wires, everything becomes guesswork. And I do not want guesswork. Inside that regulator, there are a few sections doing real mechanical work. One section is the cutout relay. Think of that as the gatekeeper. When the generator is not producing enough voltage, the cutout is open. That keeps the battery from feeding backward into the generator when the engine is not running. Because if the battery stayed connected to the generator with the engine off, the generator would try to motor. We do not want that. Then there are the sections that control voltage, and on many systems current as well. So the regulator is not just a box with wires. It is an electromechanical controller. It decides when the generator is allowed to connect to the battery, and it controls how hard the field circuit is driven. Now, before we do any electrical testing, I want to stop and talk about the mechanical condition of the generator, because this gets overlooked all the time. If you have already had the generator apart, or if you are trying to decide whether it is worth testing, I want you to look at the basics first. Look at the brushes. Are they in good shape? Do they have enough length left? Do they move freely in the holders? Do the springs put good pressure on them? Now look at the commutator. Is it reasonably clean? Is it badly burned? Is it black from arcing? Is it rough or grooved? If it is dirty but otherwise serviceable, clean it up properly. A little crocus cloth works well for that, not something aggressive. Just enough to clean the surface and remove contamination and glaze. If it is badly damaged, that is a different matter. But if it is just dirty, clean it correctly. Now check the bushings or bearings. Are they good? Is the armature running true? Any looseness? Any drag? Any rub marks? Then look over the armature. Do you see anything obvious? Any overheating? Any rubbing? Any physical damage? If the generator has mechanical problems, fix those first. A lot of people want to jump right into electrical testing. But if the brushes are hanging up, or the commutator is filthy, or the bushings are worn out, the machine is already telling you where the problem begins. So get the mechanical side right. Then put the machine back together, then test it. That is the right order. Now, if you have a full test bench, that is wonderful. That is the optimized way to do it. I have used test benches for years, but most people listening are not going to have one. So I want this taught using the vehicle itself as the drive source. Let the engine spin the generator, just like it does in real life. And for the key test, we are going to use one of the simplest tools there is, a plain incandescent lamp. A regular tail light bulb will work fine. A dual filament tail and stop bulb is fine. The exact bulb is not the big issue. The important thing is that it is incandescent. Do not use LED for this. An incandescent bulb is simple. It gives you a visible response, and it does not create the same polarity confusion that an LED can. So if I were talking you through this over the phone, I would say this. Take a standard incandescent tail light bulb. Put 2 wires on it. Make yourself a simple little lamp with pigtails. That is your test tool. Now let's talk for a moment about motor testing. When you motor test a generator, you are intentionally feeding it current, so it spins like a DC motor. That tells you a few things. It tells you the machine can motor, it helps confirm direction of rotation, and it helps establish correct magnetic polarity in the pole shoes. That last part matters because the machine may be going into a positive ground system or a negative ground system, but I want to be clear. Motor testing is useful. It is not the final proof of charging ability. A generator can motor and still have trouble self-starting when driven in service. So now let's slow down and talk about A circuit and B circuit logic, because this is where many people get mixed up. On an A circuit generator, one side of the field is connected internally to the armature side of the circuit. So for the test setup, the field terminal is jumped to ground. On a B circuit generator, one side of the field is connected internally to ground. So for the test setup, the field terminal is jumped to the armature terminal. That is worth repeating. A circuit, field to ground. B circuit, field to armature. If you remember that, you are a long way ahead already. Now the motor test itself is mostly a shop procedure. Most people are not going to do that out in the yard. So I mention it because I want you to understand what it proves and what it does not prove. It proves the unit can motor. It helps with polarization. It helps confirm direction. But it does not by itself prove that the generator will start charging correctly on the vehicle. So now we move to the test. I really want you to understand this is the self-start test using the incandescent lamp. This is the test that answers the real question. Can the generator wake itself up and begin producing output on its own? Here's how I walk someone through it. First, make sure the generator is mechanically fit for service. Brush is good. Brush is moving freely. Commutator clean, bushings or bearings good, no obvious physical problems. And second, know whether the system is positive ground or negative ground. That matters. Third, identify the generator terminals, armature terminal, field terminal, good ground through the case or a dedicated ground connection. Then identify the regulator terminals, battery terminal, armature or generator terminal, field terminal, ground if there is one, load terminal if there is one. Now the generator needs to be isolated from the regulator for this self-start check. We want the generator standing on its own for a moment. We are trying to prove whether the generator itself can begin making output before the regulator and battery are brought back into the picture. So take your time with the wiring, tag the wires if you need to, do not rush it. The wire from the generator armature terminal normally goes to the regulator armature or generator terminal. The wire from the field terminal normally goes to the regulator field terminal. Know what you are disconnecting. Now take your incandescent test lamp, connect one side of it to the generator armature terminal, connect the other side of the lamp to ground. That puts the lamp in position to respond when the generator begins producing output. Then make the proper field jumper. If the generator is A circuit, jumper the field terminal to ground. If the generator is B circuit, jumper the field terminal to the armature terminal. That is your setup. Now stop and think about what we have built. The engine is going to spin the generator. The generator is isolated from the regulator. The field circuit is arranged according to its design. And the lamp is connected so it will tell us whether output begins to build. Now start the engine. Let it idle. Stay calm. Do not race it. Bring engine speed up only as needed. And watch that incandescent lamp. If the generator is healthy and polarized correctly, the lamp should begin to glow as speed comes up. And that glow is very meaningful. That lamp is telling you the generator is beginning to produce output on its own. That is the self-start event. That is the generator waking up electrically, using residual magnetism, using rotation, beginning the charging process. That is much more meaningful than simply knowing it can motor. Now, once the lamp responds, do not keep holding engine speed up longer than necessary. You have proved your point. Bring the RPM back down. Shut it off if needed. Do not abuse the machine. You do not need to prove it twice. Now let's say the generator does light the lamp. That tells you something very important. It tells you the generator itself is fundamentally capable of waking up and producing output. At that point, if the system still does not charge once everything is hooked back together, your attention shifts toward the rest of the system. Now you start thinking about the regulator. Maybe the cutout is not functioning properly. Maybe the regulator contacts are poor. Maybe the regulator is out of adjustment. Maybe the wires are wrong. Maybe the grounds are poor. So now reconnect the system carefully. Generator armature terminal back to regulator armature or generator terminal. Generator field terminal back to regulator field terminal. Battery feed where it belongs. Grounds clean and solid. And this is where I want to say it again. Do not underestimate grounds. Paint under the regulator. Rust under a mounting bracket. A poor engine ground. A weak connection between the generator case and the engine. Any one of those can make a good system act like a bad one. So clean metal matters. Solid ground paths matter. Oh, and if there is a dedicated ground terminal on the regulator, use it properly. Now let me tell the story the way it often happens. A fellow calls and says, my old tractor is not charging. So I start asking questions. Has the generator been off recently? Was the regulator changed? Was battery polarity changed? Did somebody rewire it? Was it polarized after installation? Are the brushes in good shape? Is the commutator clean? Do the brushes move freely? Are the bushings or bearings worn? Can the generator self-start with the lamp test? And as that conversation goes on, the real problem usually starts to show itself. Because these systems are simple, but they do not forgive mistakes, wrong polarity, wrong wiring of poor grounds, field and armature wires crossed, bad regulator contacts, dirty brush tracks, weak brush springs, all of those things can make the system fail. But once you understand how the system is supposed to work, you can reason through it, and that is what I want you to learn here. Not just a test, a way of thinking. Now, I also want to say something about old-timers who did these every day. There were men who rebuilt generators all day long, and they could tell a lot by the way a generator motored. They knew what normal sounded like. They knew what normal felt like. They had a sense for it, and there is truth in that kind of experience. But for the average person, especially someone who only works on these once in a while, I do not want the whole diagnosis to come down to, it seemed okay to me. I want a more disciplined sequence. If it is mechanically sound, that matters. If it motors, that tells you something. If it self-starts and lights the incandescent lamp, that tells you something more important. If it then reconnects to the regulator and charges properly in service, then you know the system is functioning as a whole. That is practical testing. That is disciplined testing. And it keeps you from throwing parts at the machine. Now let me give you a few closing cautions in plain language. Do not use an LED test light for this job. Use an incandescent bulb. Do not lose track of polarity, positive ground and negative ground matter. Do not assume every generator is wired the same way. Know whether you are dealing with A circuit or B circuit logic. Do not ignore brush condition. Do not ignore commutator condition. Do not ignore bushings and bearings. A dirty or worn out machine cannot be wished into good electrical performance. And do not overlook grounds, honey. Grounds matter on these systems every bit as much as the hot side does. That is one reason I still enjoy working with generators. They are understandable. They are honest. They reward careful thinking. And if you slow down and learn the sequence, they make very good sense. So if you remember nothing else from this episode, remember these 4 things. A generator must be able to self-start. A motor test is helpful, but it is not final proof. A circuit and B circuit hookups are different. And a simple incandescent lamp can tell you a great deal if you use it correctly. That is basic generator testing in a form you can carry right into the shop, or the barn, or the shed, or the garage. Yep, and that kind of understanding still matters. Closing. If you enjoyed this episode, make sure you subscribe to Test Equipment Chronicles with Bob. Give me a thumbs up. Share this with someone who still works on old tractors, collector cars, generators, starters, and vintage charging systems. I appreciate you spending your time with me. I'm Bob. Thanks for listening, and I'll see you next time.